Our next speaker, Adam Zadrożny, is joining us remotely, and he will present natural language processing of astronomical transients reports. Interesting.
Okay. So I'm from National Center for Nuclear Research in Poland, and the project that we started to working is connected with allowing the computer to read what the astronomers to analyze the GCN circulars and astronomical telegrams and extract the data from it. Basically, many of the very interesting parts, the stuff that we are working on is a time domain astronomy. There are many phenomena that are very time constraints, and if you would like to get most of it, we need to get the data. And usually those hunting for GRB afterglows or for trying to observe the kilonova requires a lot of instruments. And over a very certain of time, the kilonova is a bit easier to catch because it's visible for a 60 centimeters telescope for more than 1 day. But with the short GRBs, the time to get the data is very small, and usually we got from the GRB satellites an information that there was a GRB, where it was. More or less we know the area, but then we need to hunt them. For the most short GRBs, we don't catch the afterglow. Sometimes the important information about the position is covered in the GCNs, and the large observatories have the people on call to read GCNs, like they could do it live, but the small ones does not. And there is a gap because sometimes from the GCN you can learn, okay, there is the transient is positioned right there, the candidate for the afterglow, or we check this area and we have the upper limit, so there is no afterglow in this area. But we cannot read it by the computer. Of course, and the project that I'm working on is try to allow the computer to get it. The GCN, when we in the 90s, where we tried to hunt for the, I remember this when I was in the primary school. The people were trying to observe the first GRB afterglow. There was a GCN network connected, which allows the gamma ray satellites to send the information about the GRBs observed, and also to the telescope to send the circulars with the observations and what they observed. So here is there's also the astronomical telegram, which also allows to communicate the results of observation, not going through the peer review, which is very lengthy process. So if we look on this text, we have what we have here is it's basically a text that we observed that there is some position of the source, and we have some information about what was the exposure time, what filters were used, and so on. Similar stuff we have here with search for counterpart to IceCube with Antares and what we get here. This is really nice stuff if you are a human, but for a computer this is a nightmare because this is written in a quite specific language, but still this is the language. It's not the data that we can just read through Python. And one of the most important cases when the going through the GCN was crucial was the observation of the trying to hunt for the first kilonovae. The SWAP was the first one to observe, and if the team were able to read GCNs, they got the observation at the same time at SWAP, maybe 1 hour later if it was in the observing field. But this event was unique if you look on the events that were delivered by the LIGO and Virgo detectors, because it was very well localized. The localization was really good, So only 40 square degrees. In O3, we did not have such a great localization. We also did not have the GRB counterpart to any of the mergers of two neutron stars. But in O4, we expect to have a better localization, maybe not so good as in case of GW 170817, but still good. Okay, so how we can process the language? Basically, if we look on the reading the GCNs, we could the way that we approach it in the 90s to just chop it into the words would not work. What we need to efficiently do it is to use transformers. I would say that it's quite an old technique because it's from 2017 and it's now perfect. Over the time we are the people working on NLP deliver better and better models. But the idea behind using the changing the paradigm how we deal with the language with AI was to try to learn to teach the neural net, the huge model which have the millions of parameters hidden inside, to deal with language as a human. So, for example, to mask some parts and allow it to guess what the word was behind. But this allows to if we train the model like BERT, if we trained on the gigantic corpus, then we can fine tune it for a certain task. For example, the question answering. So what we basically doing, we are asking a question to the text and trying to the neural model to highlight the part that is best fitting for our question in the natural language. So here we have the text regarding observation of the trying to get what was the redshift to the some GRB by observing the afterglow. And what we can get, we can ask the question in natural language, what was observed, and then we put the text of the GCN as a context to this question, and we can get, okay, the answer is optical afterglow. What are the position in text? So this is the position of this part in text, and how well it fits the question. Of course, it means that we put first the question, then we put a text that we are trying to ask the question to, and we got some answer from the text. Of course, if we formulate the question badly, so what was detected? It would be the continuum, but the reason why we got this answer is because here was a key phrase that we detect something, but the language used here was observed as a one. Okay, but if we ask another question, what was the redshift? We immediately get the answer. We can extract by using the question in natural language from GCNs. We can extract the viable data. What was the time of observation? So here we just got the information about the observation part. So why we are trying to build the pipeline for processing it? The key reason is that if we have the automatic telescope somewhere in Chile or in South Africa, and we are not having the people on call, the computer could read the stream of GCNs for observation of kilonova in O4 and notice, okay, here we got the upper limits, and the upper limits are better than the depth of our telescope. So probably there is nothing there. We don't we cross out those fields, or there is observed some kilonova. So let's go there, get the data, get it fast, and this question answering pipeline, of course, on top of it, there needs to be put some additional filters, could interfere by reading the GCN stream with scheduler and saying, okay, those fields we cross out, to those fields we got, this field have a higher priority. But this is not all. We also could do the volume analysis of GCNs and ATOs. There is about 50,000 of ATOs and about 300,000 of GCNs that we can do the analysis, the text analysis, and analyze this data by using the time and the volume, and maybe search for some patterns that we see, some variabilities that were observed and not linked because we could not efficiently processing the language. The efficient language processing is only last 4 years since the transformer models came into play. But what I would like you to get from the talk is that it's clearly possible to read GCN circulars and astronomical telegrams by computer. Our project will be publicly available as a Python package quite soon. And to analyze the language, we need the transform-based models to do that. And at first, we can use the BERT model for question answering, but it would not be enough. It has to be trained for the domain-specific language. We need to add also some stuff on top of it. Yes? Okay.
Okay, thank you very much. We have some questions that have come in on Discord. James is asking, would creating machine-readable standards for the additional/extracted metadata avoid the need for multiple groups to rescan the archive?
Yeah, it would, but the problem is, the key issue is that sometimes you need to add some commentary if you get something unusual. And yes, of course, the machine-readable standards will be nice. There is some formulation of text that are much easier to read by machine than others. But still, we have the GCN archive, and we could dig through this. We cannot change what was going. We cannot reformulate the past stuff, but in the future, yeah, we probably will have some machine-readable standard that would be better. But for now, for 04, I guess it might be highly important to have the tools like that.
Thank you. I think we'll get one quick question and then we'll move on. There'll be more questions in Discord for you to answer. So Sergi asks, how do you train and evaluate your model with astronomical data?
Well, this is with the language. If we have the model that it's generally used for the question answering, then we need to prepare the additional set of questions and answers from the GCN text to additionally fine-tune the model.
Okay, thank you very much again.